Hi everyone, today I want to show you how to use Holistics and AQL to create this report. This is a order quantity distribution analysis, and it's very useful because it shows that the majority of orders fall within a few key quantity ranges. For instance, a significant portion of the orders falls between 1 to 6 items per order. This information can help focus on optimizing operations, pricing, and inventory. Similarly, you can use this information to prioritize resources such as marketing, customer service, or logistics on these high-frequency order sizes to maximize efficiency and customer satisfaction. So the x-axis represents the order quantity. So for this data point, for example, there are 8,000 orders with just one item, and it represents about 25% of total orders. So this line here represents cumulative percentage. If we choose this data point, then we can read it like we have 2,800 orders that have 4 items, and there are about 65% of total orders with 4 items or less. So this is how you read this report, and this is also the end result that we're looking to produce today. So how we're going to build this report? So let's get started. Now, before jumping into the details, I want to bring your attention to some of the models in this dataset. We're not going to go through all of the models because it's just overwhelming, but there are some models that we should pay attention to. And in this particular example, I want to bring your attention to the order model, the order item model, and the product model. So naturally, an order can have multiple items, and each item corresponds to a particular product. And we also see that there is a quantity filled in the item. So you can purchase 3 toothbrushes, 3 books, 4 handkerchiefs. So that's an example of quantity. But we don't have a quantity on the order level. We only have quantity for the item level. So the first thing that we have to do is to create a dimension that's called order quantity, that basically sums up all of the quantity in an item and aggregate those numbers up to the order model. Now let's go to the order model and create a new dimension that's called order quantity. And like I said, we will sum the quantities in order items into the order model level. So if we just write it like this, then this AQL expression will sum quantity across all order items in our database. Our purpose is to aggregate the quantity up to the order model. If we write it like this, then we will not be able to achieve that purpose because the quantity is going to be summed up across all order items. So let me just run this and see how it works. So this is the order quantity if we just write an AQL expression like this. Like I said, it is summing up across all of the order items. This is not the dimension that we want to calculate. The x-axis represents possible order quantities. We don't want to just have one number. We want to have a list of order quantities like 1, 2, 3, 4, 5, and things like that. So what we can do is to add a exact range functions to this AQL expression, and I will specify the grains to be orders ID. So the exact grains function is telling AQL to evaluate this expression at the grain that we are specifying. In this case, is the orders ID. So by specifying the orders ID, the sum will be evaluated for each orders ID. So let me just go ahead and run this. As you can see, it lists out all of the possible order quantities for all of our orders. So next, we will calculate the total orders for each of these order quantity. So this is simple. So for this, we will just go ahead and create a matrix, and we just need to count all of the ID in the order model. So I will call this total orders and get result. Yep. So as you can see here, we have the total orders metric for each of the order quantity. So we are halfway there. Now, the remaining of this video, I'm going to show you how to calculate the cumulative percent of total for these total orders. So what I mean is that we will calculate the percent of total for each of these total orders. So we will go ahead and create a matrix, and I will call this percent of total, and I will take the total orders matrix and I will divide it by the total order matrix. Now this does not make sense because it will always return the number 1. But what is interesting is this total order matrix, instead of calculating the total order for each of the order quantity, what we want to do is we want to calculate the total order across all of the order quantities. So we don't want this metric to be constrained by the order quantity dimension, but we want it to be evaluated across all of the orders. So for that, I can write something like this. I will use the of all function, and I will specify the orders model. So this of all function is telling AQL to evaluate this metric at the grade that we are specifying. So we are specifying the order model, so we will not evaluate this expression based on the order quantity dimension here in the exploration UI. So this is the meaning of the of all function, and I will hit get result to see how it works. Yeah, so as you can see here, the percent of total metric is the total order for each of the order quantities divided by the total orders across all of the orders in our database. So this is the percent of total metric. Next, we want to calculate the cumulative percent of total. So it's just a simple sum. So we want to sum this row with this row for this particular order of quantity. For example, for this order quantity, we want our cumulative percent of total to be all of these numbers summed together. So this is why we call it cumulative percent of total. Hopefully that makes sense. I will go ahead and also create a matrix, and I will call this cumulative percent of total. And for this purpose, it sounds complicated, but in AQL we have a function called running total that was designed for this exact purpose. So for running total, you just need to specify the metric that you want to evaluate this running total on. So this running total function will calculate a metric from the starting of time to the current period, and basically we want to use the running total on the percent of total metric, and we want this to be evaluated based on the order quantity. So I will specify the order quantity dimension. And with this AQL expression, we are essentially telling AQL to sum all of the percent of total for each of the order quantity dimension. So this should be order quantity dimension, and get result. Yeah, so this looks correct. So this cumulative percent of total is for a particular order quantity. Take the percent of total for that particular order quantity and sum it together with the percent of total for the previous order quantity and the previous ones. So this looks correct to me. We can go to the format tab and choose a custom format so that we can specify the percentage format and it will look much better. Yeah, so this looks neat. So final step, we just need to use a combination chart to create the final report. And with this combination chart, we can specify multiple y-axis. So for this report, I don't actually need the percent of total matrix. We just need this to calculate the cumulative percent of total matrix. So I can just remove it from the report, and then I will specify the cumulative percent of total to be the second y-axis. And for the total orders, we can use the column, and for the cumulative percent of total, I will use a line, and then we will see our final report. Hopefully this has been useful. If you want to check out other videos, go to our YouTube channel. We have other videos on calculating percentage of total and simple aggregations and other videos as well. So remember to check that out.